Today we are talking about distance, midpoint, and bisector. And we want to find the distance between 2 points. In order for that to happen, we need to use the distance formula. The distance between any 2 points with coordinates, so point A has x sub 1, y sub 1, point B has x sub 2, y sub 2, then we can use the given formula. The distance is equal to the square root of x sub 1 minus x sub 2, quantity squared, plus y sub 1 minus y sub 2, quantity squared. And that is very similar to Pythagorean theorem, a formula that we've have seen before. In the way that it would look even more similar to Pythagorean theorem is if we solved to get c by itself. In order to get c by itself, we'd have to take the square root of both sides of the equation. So we take the square root of the left side, and we would be left with the quantity a squared plus the quantity b squared. And we know that if we take the square root of this side, we would just be left with c. So this matches up with the distance formula, where d would be replaced with c, and then our x values, x sub 1 minus x sub 2, would be replaced with a squared, and y sub 1 minus y sub 2, quantity squared, would be replaced with b squared. And then everything else is the same. We still have the plus sign in between. We still have the square root, and we still have the equal sign. So basically, the distance formula is Pythagorean theorem, where our a value is x sub 1 minus x sub 2, and our b value is y sub 1 minus y sub 2. Everything else is the same. And we have an example here that we get to look at. So calculate the distance of AB. So we want to find the distance from A to B. And what we want to do is we want to turn this into a right triangle. So we want to find the distance from A to B, which is this distance right here. And it would be great if we could count it, but we're not able to do that because it's on a diagonal. But what we can do is we can count horizontally and we could count vertically. So that's what we do. We change this into a right triangle. So we go there, and we'll be able to count that value. That's the horizontal portion, and then we have the vertical portion. All right, so our coordinates for point A, we have the coordinate 3, 2. Three, 2. And for B, we have the coordinate -4, 5. Okay. Then just as a check, we're going to count these, and then we will compare the distance formula to Pythagorean theorem. So the distance horizontally along this red line here, we count 1, 2, 3, 4, 5, 6. So that distance is 7. And our distance vertically, as we go from 2 to 5, is 3. 1, 2, 3. All right, now we will use the distance formula. So whenever I do the distance formula, I always write down the things that aren't going to change. So the things that never change. We're calculating the distance. There's going to be 2 sets of parentheses. Both sets of parentheses are going to be squared. We're going to add the parentheses together, and we're going to have the minus sign in the middle, and the whole thing is going to be square rooted. Now the parts that go inside the parentheses, we have x sub 1 in x sub 2, and we have y sub 1 in y sub 2. Now we're going to substitute those values in. Rewrite the formula. Things that don't change, we still have the distance formula. These parentheses are always going to be squared. And the minus sign, I always put the minus sign in the middle because sometimes we add in a negative value and we want to make sure we keep that minus sign. So x sub 1 in this case is going to be 3. X sub 2 is negative 4, and this is a great example where the negative already is there, so I have to add the whole thing, which is negative 4. Next one we have is our y value, which is y sub 1, which is 2, and y sub 2, which is 5. Okay, now we just have to do the math inside these parentheses. So 3 minus a negative 4 is actually adding. So 3 plus 4 is 7. And we still want that to be squared. And then we're going to add 2 minus 3, and 2 subtract 3, that's going to be negative 3. And I put this parentheses on here on purpose to make sure that if we ever have a negative value, we include that in the square. So the value of 7 squared is 49, plus negative 3 squared is positive 9. And we're still calculating the distance formula, and that's going to be squared. And then we have 49 plus 9, which is 58. So the distance is equal to the square root of 58. And if we plug that in our calculator, the distance is approximately equal to 7.6. Okay, we can do the same thing to calculate that distance of 7.6 right there. We just calculated that approximately. We can do the same thing without using the coordinates, just by counting. And we did that right there. So because it's distance, we don't usually keep the negative sign. We only kept the negative sign there because of the coordinates that we used. But once we square it, that negative sign disappears anyway. So we could go right into Pythagorean theorem, where our hypotenuse would be equal to c. Then we'd have an a value, and we'd have a b value. So we could set it up one of two ways. Pythagorean theorem is going to be c is equal to the square root of a squared plus b squared. And we can solve it just the same way that we did. Now we're just going to substitute in the value. So a is 7. We don't know what c is, so c is going to remain c. We know that a is 7. So we have 7 squared. And we're going to add, and we get b squared, which is 3 squared. So the value c is equal to, we know that 7 squared is 49. And we got 9, or 3 squared, which is 9. And square root. And we get the same values. So 49 plus 9, that's c is still equal to the square root of 58. And so c is approximately equal to 7.6.